Hi everyone, I am Dr.A.Sethupathy, Assistant Professor, Department of Mechanical Engineering, SNS College of Engineering, Coimbatore. I welcome you all for my video lecture. So today we are going to see about the transducers and what are the types and what is the work of transducers. So in transducers, it is used in the mechatronic systems. So which one is called the mechatronic system? That means the mechanical and electronic systems integrated with the machine or any equipment or any serviceable work done by that. So that is called the mechatronic system. So what is transducers? So in this presentation covers four main type of transducers. So transducers means sensors. So the sensors we are using for sensing the areas which we need to convert the pulse into signals. That is called the sensors we are used. For example, we are using the thermometer using the heat sensors that is converted in the thermal heat into degree of Celsius or degree of Fahrenheit. So the atmospheric temperature will be measured by or sensed by the sensors and converted into what's the reading of the temperature. The same like so many devices we are using the sensors. So in this video, we will going to see about the main four type of sensors, that is resistive and capacitive and inductive and resonant. So these four type of transducer, that is sensors, we are overview in this video. So each type has distinct principle of operations and applications and characteristics that make them suitable various measurements and sensing areas. So these four different type of transducers we are using in the different type of sensing areas. Okay, we will see the first one, resistive type transducers. So these transducers are these sensors we are using such a physical phenomena. So this will be resist the change in the physical phenomena such as temperature, pressure or displacement areas. We are using this resistive transducers. So this is operating based on the change in resistance due to physical phenomena. For pressure sensors, we are using this sensor. We apply the load by physically. The sensor will be giving the output of how much amount of pressure we will use it in this device. So same like temperature, we are using the thermometer, digital thermometers, the sensor used in the end of the thermometer. The sensor will be touched by the human body. The body, that is called the physical touch. So the sensor is operating and converting the temperature into digital data. For displacement in one area to another area, the distance or how long we travel, these type of applications we are using the resistive transducers. So this is the common type and include thermistors for temperatures. For temperature sensors, we are using thermistors and measurement strain gauges for using pressure measurements. So these are all the common type of resistive transducers. And what are the advantages and disadvantages? So this is simple and low cost and easy for use, but can affected by the environmental conditions and may have lower accuracy compared to other type of transducers. The accuracy of these transducers will be lower than other transducers, but cost wise very low, simple and easily affected by the environmental conditions. The another type is capacitive transducers. So these operating principle, it is measured changes in capacitance caused by variations in distances, so pressure or material properties. So the output is typically a voltage change proportional to the capacitance variations. So this is the output of voltage difference between initial voltage and final voltage. We convert the data. So these capacitive transducers widely used in pressure sensors, and another one is displacement sensor and touch sensors. So it's mostly used in the electronic devices. So the high sensitivity and accuracy. So these transducers have high sensitivity and more accuracy compared than the previous one. So what are the advantages and disadvantages of this capacitive transducer is highly precise and stable. This is the advantage, but the disadvantage is susceptible and interface from external electric field and require useful calibrations. So the calibration is very important for this capacitive transducers. So another type is inductive transducers. This inductive transducer works on the principle of electromagnetic induction. So the output is change in the magnetic field induces a voltage in a coil. So these type of outputs given by these inductive transducers. So this is used in the position sensors and metal detectors and automation industries. So what is the advantage and disadvantage of this type of inductive transducers is it can operate in harsh environments. So the environment not easily affected by this inductive transducers, but limitations in range and sensitivity. So the range between the 2 points is very less, and the limitations of the distances compared to other sensor, this is low. So these are all the advantages and disadvantages of this inductive. So another one is resonant transducers. So this is operated by the principle of resonance. Output signal is the frequency of an external stimulus. So they are particularly sensitive to change in mass or environment conditions. So in this resonant transducer, we are using frequencies. So it is usually in wireless communications and some other television relays, telecasts. So these type of resonant transducers we are used for application of this transducer is pressure sensors and accelerometer. So the accelerometer is to find the vibration and frequency of the machine shafts, and the advantage is high sensitivity and precision, but the disadvantage is complex design and may require specific operating conditions and functions. So these three type transducers have different applications and different advantages, and operating condition also difference. Thank you.